All right, hello everyone and welcome. So, you're getting ready for your big physics exams, right? WAEC, JAMB, NECO, you name it. You know that waves is one of those topics you just have to nail. Well, in this explainer, we're going to do exactly that. We're going to crack the code, solve some real problems, and make sure you walk in there feeling confident. So let's just jump right in with a tough one. This is a real JAMB exam question. Now I know what you're thinking. That equation looks pretty scary, right? But I promise you, by the time we're done here, you're going to look at this and know the answer in seconds. Seriously. First things first though, we need to build our toolkit. Okay, first up, let's build your essential wave toolkit. Think of this as packing your bag with all the gear you need. These are the absolute core ideas and formulas that will let you solve pretty much any wave question they can throw at you. So, what even is a wave? At its heart, is just a disturbance that moves energy from one place to another. You know, like when you see ripples in a pond. The most important thing to remember, and I mean write this down, is that waves transfer energy, not matter. The water itself is just moving up and down. It's the energy that's traveling across the pond. Now, waves basically come in two main flavors. First, you've got your mechanical waves. These are kind of the needy ones. They absolutely need a medium, some kind of stuff to travel through. Sound needs air, right? Ocean waves need water. But then you have electromagnetic waves. These guys are the ultimate explorers. They can just cruise right through the total emptiness of space. That's how light from the sun gets all the way to us. We can also sort waves by how the particles, how they wiggle. In a transverse wave, the particles move up and down at a right angle or perpendicular to the direction the wave's energy is going. It's just like doing the wave in a stadium. But with longitudinal waves, the particles vibrate back and forth, parallel to the direction the wave is traveling. The best example is a slinky. You push one end, and you see that compression move all the way down. And guess what? That's exactly how sound travels. Okay, listen up. If you only remember one formula from this entire explainer, make it this one. This is your master key. It unlocks so many calculation problems you're going to see on your exam. It is absolutely crucial. So simple, right? But so powerful. V equals F lambda. So V is just the wave speed, which we measure in meters per second. F is its frequency in hertz. That's just how many waves pass by a certain point every second. And that funky symbol, that's the Greek letter lambda. And it stands for wavelength, the distance from the top of one wave to the top of the next. And the last thing for our toolkit, these four key behaviors. This is all about how waves act when they run into stuff. You've got reflection, which is just bouncing off a surface. Think of an echo. Then there's refraction, which is when a wave bends as it goes into a new medium, like how a straw looks bent in a glass of water. Diffraction is how waves spread out when they squeeze through a little opening. And interference, that's what happens when two waves crash into each other and combine. All right, our toolkit is packed and we are ready to go. It's time to enter the gauntlet. Let's take what we've just learned and throw it at some real past questions. You're about to see how well this stuff actually works. Okay, here's our first fight, straight from a WAEC physics paper. So you've got these waves, they go through a tiny opening, and then they spread out in circles. Which one of our four properties is that? Just take a second. Which one fits? And if you said B, diffraction, you are absolutely correct. Let's just quickly break down why that's the one. See, this question is the perfect proof that just knowing your definitions can get you easy points. The keywords here are narrow gap and the waves becoming circular. That is literally the textbook definition of diffraction. These are the kinds of questions you want to see. Quick, easy marks as long as you've got your toolkit memorized. All right, next up, a question from NECO. This one's all about classifying waves. They want to know which of these is longitudinal. So remember, what does longitudinal mean? It means the vibration is parallel to the direction the wave is traveling. And the correct answer is B, sound waves in the air. And it's pretty clear why when you look at it this way. Light is an electromagnetic wave, so it's always transverse. A wave on a string, well, the string moves up and down while the wave moves forward, so that's transverse too. And that just leaves sound. Our classic example of a longitudinal wave, moving as those little squished up compressions in the air. And here we go, is the final boss of our gauntlet. The scary looking question from the beginning. But this time is different. Now we have our toolkit, and we are totally ready to solve this thing. We need to find the angular frequency. The answer is 500 radians per second. Yeah, that's it. So how in the world did we get that so fast? Well, it's not about complicated math. It's about knowing the secret code. So here's the secret. The trick to these problems is just pattern recognition. You just have to know the general wave equation, which you see right there. Then all you do is you just line it up right underneath the equation they gave you in the question. And you just compare them. You see that the angular frequency, that little omega symbol, is always the number right next to the t. And in our question, that number is 500. It is literally that simple. No crazy calculations needed. And there you have it. You've made it through the gauntlet. Now, to wrap everything up, let's go over a few final rapid-fire tips. Think of this as your master key to lock in those top marks when it really counts on exam day. Okay, you ready? Don't ever forget your units. Meters per second, hertz, whatever. Examiners live for that stuff. If you draw a diagram, label everything clearly. Burn this into your memory. Sound is longitudinal. Light is transverse. Get some practice actually drawing what reflection and refraction look like. And, like we just saw, be a detective with those wave equations. Look carefully at what each number is and what it represents. And that's it. Really, you've got the toolkit. You've seen how to use it against real exam questions. You have the strategy. You are now officially exam ready. The only thing left to do is practice, 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 and then walk into that exam hall knowing you've got this. So I'll leave you with one last thought. We've mastered the exam basics, but the world of waves is way bigger. You've all heard an ambulance siren, right? Ever wondered why the pitch goes from high to low as it speeds past you? Well, that's called the Doppler effect, and it's another awesome piece of the wave code. So keep being curious, keep learning, and good luck on your exams.